Ladies and gentlemen, well, today I'm going to be talking about the AMES, the 12-in-1 infrared laser thermometer. It's ruggedly built from Harbor Freight. It's a 12-in-1, which means that for every 12 inches you have 1 inch of laser hitting your space. And it's not the laser, it's 1 inch of a space that it's taking its average off of. So this is, so far, seems to be pretty durable. It's got a little bit of a learning curve to it, because unlike my other one, which was this Craftsman, which was a 6-in-1 infrared, which meant for every 6 inches, I had to be 6 inches to have that 1 inch average space. The further I got, the bigger the space I was actually averaging to get my temperature reading on here. And another thing was that on here it has an E.95. That's the emissivity of that thermometer. Now this one, as you can see here on this nice little picture they give on the back, you get 1 inch at 12 inches, which is 1 foot of a spot that it's actually averaging and getting the temperature off of. At 2 feet you're gonna have 24 inches, and at 4 feet you're gonna have 48 inches, which is a 4-foot spot you're averaging. So just because you see your laser like there, I'm not actually measuring just there up on that wall. I'm actually measuring, that's about 2.5 feet. I got at least a 2.5 inch spot that I'm averaging up there. Instead of the I said it wrong, I said 48 inch spot you're measuring. It's at 4 feet away, you got a 4 inch spot you're measuring. But let's see, the specifications of this is you have minus 50 Celsius to 550 Celsius. Which, let's go into English now, because I'm in America and nobody here does Celsius. But whenever I go visit the in-laws, that's all they do is Celsius. I'm starting to get a scratchy throat. I've been sick for the last couple days. So for Fahrenheit, we go negative 58 Fahrenheit all the way up to 1022 degrees Fahrenheit. And it is saying its accuracy at minus 58 degree Fahrenheit to 32 degrees Fahrenheit is plus minus 7 degrees. That's a pretty big swing. That's a pretty big swing there. But then from 33 to 122 degrees, it's plus minus 4. Now, yes, that emissivity makes a big difference with these. Tell you the truth, I bought this for testing radiant heat on floors, so I wasn't crawling around on my hands and knees. But I found that this just sucked for half of the things I actually needed to test. It was no good. This at least has a chance. I have to take a major learning curve with it, because the problem is that these both have the same problem, and that is the emissivity of an object. So that's why I've set up a few different things on my table. I got a ratchet, a cold beer, I don't even know why I have 2 of the same exact things here. So let's remove this. I don't need the volute there. I have a bearing assembly and a volute of a pump. I have a bottle opener. I have 2 shiny stainless steel plates right here, some paper, and a piece of sheet metal on the floor. This thermometer, the AMES Infrared Thermometer, the 12-in-1, inside this cardboard is this nice little book. I've been using this at work. There's a video, and I will throw up a spot if you want to go watch this video, and I'm also going to put a very small part of the video into here. But I use this thermometer on a breaker panel to help me locate a loose wire on a breaker that was tripping because it was overheating. So I mean, I've used it. It is pretty durable, but I do have to say, from being in my toolbox, its display is already getting a little scuffed up. I mean, he did not get as scuffed up, and he took the ride even worse than this one has. This has been in my toolbox for several years, bouncing around who knows where, because half the time I don't even care about that. But the nice thing about this is, let's just look at the display. Here we go. The display lights up pretty bright. So I mean, you want to hit your object, you want to test it, you see what you have on that object. You want to hit another object and test it. Now, I mean, you got the shininess. Now, a problem with the shininess stuff is I'm not sure, am I testing my, this thing is blasting me in the nose. I don't want to hit my eyes, but am I testing myself here? Because, let's take it off me where the reflection's not hitting me. Okay, now the reflection's not hitting me. So if a material is shiny enough, you're going to get a reflection, and it's not actually reading the surface of this. I believe it was reading my reflection somewhat. Now we have a cold beer. And I mean, the glass, it is reading it. But I don't know if it's actually reading the exact temperature. But it's at least giving me an idea. But then we have this thing, like I said, called Emissivity. Emissivity is adjustable on here, which is great for my sore throat. Let me just help myself out with a little vitamin A here. That's a good beer. But now back onto this. Inside these instructions, it gives you a little tiny chart that tells you the emissivity of different objects. It says glass is 0.95, which is where it's coming from the factory. Concrete is 0.95. Hot food is 0.93. Carbon is 0.85. Cast iron is 0.8. Copper is 0.5. Galvanized pipe is 0.4. Aluminum oxidized, because you see copper oxidized, which means dirty. That is a little beef I might have with this, and I'm going to tell you about that in one second. But you see the stainless steel polish 0.2. Here's polished stainless steel 0.2. I'm getting 76 right now. So to adjust your emissivity, you hold that till the E flashes. Then you adjust this down all the way to where you want to go. Stainless steel polish is saying 20. Okay. 20. Now you hit select again. Okay. Now, boom. It's hitting me. Boom. Like, see, it's straight on an angle, but then you put some tape on it, and that will throw it off, because the tape actually, for years I was always taught with these infrareds, especially this one, you put some tape on your copper pipe, and well, it works better. Now, let's look at this real fast. Okay, here's a chart I found on thermoworks.com. It's an emissivity table. But what it also tells you on here is that the accuracy of the following figures is almost impossible to guarantee, as the emissivity of a surface will not only alter with regard to texture and color, but also with its actual temperature at the time of measurement. We would recommend, in the first instance, comparing measurements found with an accurate surface probe or wire probe. And then the infrared thermometer can be adjusted to match the correct emissivity and used for a I can't even say the friggin' word right now. Subsequent measurements. Okay. They take no responsibility for this chart. But now, here I am. I do HVAC, so HVAC is very important. Copper, shiny pipes and whatnot. I need to be able to test boiler pipes. I want to test air conditioning pipes. Asbestos has very high, at least. So I'm not too worried about the emissivity of asbestos. It's got pretty high. But now when you get the copper, boom, polished, 0.05. This doesn't go that low. Oxidized, 0.65. Okay. It's a little different though than what they say here, 0.5. But like, remember they said they can't take responsibility. Let's go down. Let's see. So stainless steel, 0.59. Alright. There's all different numbers here. There's only one, which is paint 3M black velvet coating, that is actually at 1, a full solid 1 emissivity. Let's not bore each other with emissivity. Now, at 95 on blue masking tape, I have 76. On T2, I have 75. Yeah, that's close enough. And I'm getting the same reading on T1. Okay, let's go to the black tape. Okay. But let's go to the copper. And the emissivity, you can see, is kind of making it go up a little higher than it actually is. And that's because it's a shinier pipe. Now let's hit the oxidized part of the pipe. But we're above copper, so I mean, now let's turn our emissivity down just a little. Let's go down to, let's say, 85. Now we're 76. Okay, well, we're at this point, our AMES Infrared Thermometer from Harbor Freight is matching my field piece and is matching my international refrigeration product thermometer that I have taped. I just wanted to see how different the field piece one was from there. So now, what we're first, it helps if I have the hot water on. But let's see where the cold went. Cold was staying right there. So we're 77 on here, 78 we're going up, 76 there. They may not respond as quickly, both of the probes. I just want to get a hot pipe. I don't care how fast they respond. At 130 degrees here, that's a very slow responder. As you can see, I'm only at 94 there, but it's going, it's moving. 137 here. Now here's the thing, if you're doing the tape, you cannot test instantly. You're gonna have to give it a couple seconds to get to the same temperature. Now what I'm also gonna do is let's check the emissivity of water. Why not? We could even do galvanized steel if we want, but we're not gonna right now. We're at 140 here. Our water's almost full. Let's see our water. Hey, I got 141 coming out. What is my probe reading? 141. Yeah, 142 in the bucket. The pail, a little cooler, but that's pretty cool. So you can actually test water. But remember, it's a laser. Even though you're seeing the laser go through, you're even seeing a laser here, it's reading the surface of that. So, now, my probe is still not up to 140 degrees. It's working its way up. The Germans, they know how to make good beer, good tools. Okay, for whatever reason, it seems my probe here has stopped at 120. I'm still 137 up top. That's a big discrepancy, my 137 versus 120. Let's see what happens if I run the hot water for a couple more minutes. Okay, he's going up. 139 is kind of like top. It was like 140 before. But what I'm finding pretty cool is that I can shoot the water and get a reading. I'm actually getting the heat off the water. I'm getting about 140. Up, look, emissivity. And that's what I'm talking about, the pipes. I'm working on boilers and all different things, and when you got stainless steel or whatever you got, you cannot test accurately with these things. But now that I know about emissivity, hey now, let me check. I got 61 degrees Celsius water. Let's go back to Fahrenheit. I hit the button by accident. Okay. I'm not sure what's going on with this, but I don't know. Let's add a little more tape to hold it tighter against the pipe. Let's see what happens. It doesn't seem like it really wants to go up that much at this point. I'm at 143 here though. Now, if I hit that, I'm at 122. 20, what? Interesting. 98. See, emissivity. There's that emissivity. Boom. Boom. Even there, but so it's heating up. It's taking a little bit, but that is heating up. I may not have a lot of times just the tip is what's actually reading. This guy might not be on that great. I'm not worried about that, but now you're seeing the emissivity part of this. The emissivity of water, almost 150. But if you need to use this for plumbing or anything, put a little electric tape on it. And what I gotta say is, I mean, I didn't really buy this for this. Like I said, the initial reason why I bought one of these was because for radiant heat, I don't like climbing around on my hands and knees and feeling the ground. And the one that I had, that Craftsman one, I'm just not impressed. I hate to say it. I just think, I mean, I don't think anything of it. I actually, if I dropped it out of the back of my truck, I don't think I'd care. But look, now you hit the oxidized and boom, you jumped up. Now, let's go to 95, which is the factory setting. I might have to go a lot lower, but at 95 on the black electric tape. 124, 120. My emissivity's high, but like they said, everything changes. Temperature. So here I am. I'm trying to use a tool. I'm not saying this is a bad tool at all. I actually do enjoy this. This has been interesting. It's been a major upgrade from this. But here I am. I'm trying to use a tool to measure temperature. And the temperature of what I'm checking actually creates more emissivity, which means that it makes it harder for me to figure out what the actual reflectiveness of that pipe is. Which is why I recommend putting on some of this. Because right now I have, what do I have on the bottom? On the bottom I have 115. 115, 118. Okay. 119. And the shiny pipe I can't test. Okay, and then my water here at 134 right now. It's cooled off a little. So on the hot and the cold, go to T1. So for a T1 now, what we're gonna have to do is see, does anything change? We're getting 76 on here still, so still 76. Still, but this is the only way I could figure out how to test copper. It's, like I said, it says you got to play around. So in order to use this, you need to know what your temperature you're looking for is. So what's the point of this? Oh, but like I said, for me, this was purchased. Let's go to 60. Now on that copper pipe, with no tape, no nothing set up. Doesn't know what to read. It's like 90. The pipe's 144 degrees. Boom! I got 170. Did I just say 160? Yeah, 160. I'm only 145. My emissivity is like screwed. But on the copper, I should really be reading better. So I honestly do have to say I need to learn more about emissivity. I'm gonna go to 40. Let's see at 40 my emissivity. I have for T2 145. I'm getting 67. Oxidized, I'm getting 200 at my emissivity of 40. Let's bring my emissivity up to 60. 55. Still, I'm at 173. I'm nowhere near 173. I would be burning my hands in that water. Alright, so after using this AMES Infrared Thermometer for a month, I have to say there's still a lot I need to learn about it. But it did help me troubleshoot a circuit breaker with a loose wire. So it came in handy there. I can test with these if I put tape on a pipe. I'm gonna be replacing my fluke clamp meter, my clamp on, because unfortunately then I actually get the temperature of the pipe without having to tape a probe onto my pipe. For other things, yeah, this is great. But when they say it's great for HVAC, we got too many shiny things, and this emissivity is a pain in the butt. It really is. At 90% emissivity, the reason why I put this one so close, 135, 138, because I know that right now as this pipe is cooling off, it's going to be cooler here than it's going to be there. So I was playing around with the AMES 12-in-1 infrared thermometer and doing these different tests with it, and yes, I'm gonna have to learn more about how to make the adjustments. It's quite interesting of the emissivity that it's adjustable, which we will find out. Well, I will find out how it is. The response time's quick, distance to spot's nice, the reading min max is nice, and the 9-volt battery, you know what, the 9-volt battery is going to last a while. In here I don't see it being a problem having a 9-volt battery. There's so many things that have a 9-volt battery. It's a pretty good battery to have. So if you're in a market for an infrared laser thermometer, this AMES seems to be a pretty good deal. I mean, I picked this thing up for 17 bucks. It's usually $25, but I picked it up. I mean, it was a part of a tool haul video that I showed when I first got this a couple weeks ago. It was like $17.99. I picked this up. I got the breaker bar. I got a couple other tools that came along with this. But this, so far, out of everything I purchased that day, is definitely worth $17. It's even worth $25. I do want to see how playing around with the emissivity on this works out. I may even be going with a higher end FLIR or a fluke to do a comparison one day, but for now this definitely gets a thumbs up. If you need one, definitely don't hesitate to pull the trigger. Remember, it is IR and it does have limitations. At least you can make your adjustments here to try to compensate for that. I mean, when you got solid surface like wood, okay, 84 we're reading right now on the wood, but that's okay because right now it is pretty warm here. I got 80 up there. I'm getting 80 on here on the wall, so I mean, it seems to be doing a pretty good job. It can't be that bad. Most people buying stuff are not using it for professional use anyway. Some are though, like me. And I mean, I do like how that display lights up. I did all that other part of the video yesterday, and now today it's 82 down here. Yesterday it was like 75 down here. It was beautiful. Today, of course, we hit 90s again in New Jersey. So till next time, I'm Bill from Bill's Tools. I'm out.